All right, ladies and gentlemen, so we are faced with a problem here. We got to help out Justin Bieber. He is moving back to Canada, and he's planning on building a brand new house. Now, Canada, if you didn't know this, has a lot of snow in most areas. He's going to move to a snowy part. So he plans to build a roof with a pretty steep pitch, a 16-12, meaning it goes up every 16 inches or every 16 feet that it goes up, it goes over 12, right? So the units would be the same. So if it goes up 16, it goes over 12 inches. Up 16 over 12. Slope, in other words, right? Now, what angle should he set his miter saw at when cutting the rafters? If you didn't know it, Justin Bieber is an avid construction man. He loves building things. So he's going to build this house himself, and build some character while he's at it because, building things helps you build character. All right. So let's see here. It's a 16-12 pitch. So we just said that, let's see here. I'm just going to draw the roof pretty steep, right? So we said every 16 that it goes up, it goes 12 over. So this would be, say, 12, and this is 16. And it's not necessarily 16 high. So actually, let me redraw that so it doesn't seem like it's implied that it's automatically 16 feet high. So if this is my roof, every 12 over, it's 16 up. 12 over, it's 16 up, so on and so forth, right? 12, 16 up. 12, 16 up. That's my slope, okay. So we got to figure out where we're going to cut these rafters at. And remember, rafters are going to look like this. When it's cut pretty steep like that, you're going to have your rafter like this. Oop. Lost my marker there. There we go. Right, like maybe like a 2x6 or 2x8. If it's going to be holding a lot of snow, they do that so it will have the snow will slide right off. Then you got your ridge, right, and then you've got your other board coming on up. Okay, so you're going to have a bunch of 2x6s, 2x8s, whatever it might be, that are going to be cut like that. We got to figure out our angle. So how do we do that? Well, we use this thing called inverse trigonometry to figure it out. Okay, our rise is 16, our run is 12. You can almost think about this like a triangle, right? You can think about it as like a triangle here. Whee! Okay, so if I've got a right triangle, I'm really trying to find, we got a couple angles here, right? Let's find both angles. Okay, so let's see, I got 16 for this guy, I've got 12 for this guy, right? So how am I going to figure out my missing angles if I only have two sides? Well, there's this fancy thing called trigonometry. Right triangle trig is what we're going to focus on in this class. That can help us figure this out. So we're going to pop away from this for a sec, introduce some trig, and then come back to this problem. Alrighty. So we have three trig functions we're going to deal with. We've got sine, and then you'll have an angle, often referred to as theta. That means theta right there. Okay, and that equals our opposite side over our hypotenuse. I'm going to draw a triangle over here, a right triangle, and if this is our theta, this is my opposite, this is my hypotenuse. And then, oops, right angle, and this would be my adjacent. Okay. Now I've got cosine of theta, that is my adjacent over my hypotenuse, and then I've got tangent of theta, which equals opposite over adjacent. Cool. So what's important to note here is my hypotenuse is always across from my right angle. My opposite is always across from the angle in which I'm referencing, my reference angle. Okay? And my adjacent is always next to it. So let's just say I had a different triangle, and let's say that this was theta, right? Well, then this would be my opposite, this would be my adjacent, but this would still be my hypotenuse. So we can see how the opposite and the adjacent switched based on which angle I'm referencing. And they both will be important in different contexts. Okay? Cool. Awesome. America. Now, we wanted to find a missing angle in that last problem, right? So what we're actually using is inverse trig to start, and then we'll go back to regular trig. So in order to find missing angles, you use what's called inverse trig. It is notated with a -1 as like an exponent looking thing, okay? There we go. I'm going to rewrite that one a little better for you. And what we would do is you would take the, in this case, opposite over hypotenuse, inside there, and that would equal your angle. And the same would hold true for cosine. Your adjacent over hypotenuse. That would equal your angle. And tangent. I'm running out of room here. Oh boy. Tangent, inverse, opposite, over, adjacent. Equals your angle. And you will see these buttons on your calculators. If you have trouble using them, bring them to class. We'll work on it. All right, but those will be my main trig functions we're going to work with, and their inverses. The inverse, the ones in red here, to find an angle. Okay? Here we want to find, in black font, missing side. Missing side. Okay? They each have their own special purpose. Cool. And the way that we remember this, a nice acronym to remember all these fractions, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, is SOHCAHTOA. Right? Sine, S, is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So a nice acronym to remember that. Cool. Let's head back to Justin Bieber's problem, see if we can help him out. Okay, so here's where we left off. So we've created this triangle in green. We're like, we want to find some missing angles, but we didn't know how to. Well, now we do. Now I want to focus on this particular angle, okay? The reason being is that bottom left angle right there, that's our pitch of the roof. And that pitch of the roof is going to tell us what we want to use, or what we want to use for our angle on the miter saw, okay? And that'll make these guys wonderfully cut, okay? Cool. So if I'm referencing that angle down there, that red angle right now, 16 is which side? That's the opposite. That was a lovely bell halfway through lunch. All right, and 12 is my adjacent side. So what trig function uses opposite over adjacent? I believe that was tangent, yes? So if I want to find a missing angle, I would have tangent inverse of my opposite side over my adjacent side, and that will actually give me my angle, my pitch of my roof. So I'm going to do that. And when I type that onto my calculator, it's nice and easy on the TI-84, so you just hit second tangent, and it will give you the tangent inverse, and then you can put your fraction in there, 16 divided by 12. And when you do that, you get 53.13 degrees, so 53.1 degrees, about 53 degrees. That's what you're going to want to set your miter saw at if you want to make those cuts. Awesome. That's pretty rad. Any idea what that other missing angle might be? Any easy way to find it without doing trig? If you said that those two angles should add up to 90 because a triangle adds up to 180 degrees, then you are absolutely correct. If I were to subtract that from 90, I'd end up with 36.9 degrees. That's awesome. But we don't really need that other angle, at least for right now. We could use it for something else, but for our rafter to answer this question here, 53.1 degrees. Perfect. America. All right, so we got another problem here. We got Fetty Wap. He just picked up a fly new ride, and he wants to make a garage special for it. If the wall height of the garage is 8 feet, and the peak of the roof is 11 feet, what's the pitch of the roof? And why would knowing this help in constructing the garage? Well, let's draw a rough sketch. It's important to be able to draw these. Sometimes I'll give you the drawing, sometimes I won't. So let's say we got this, and then let's say we've got a roof, something like that. This is 8 feet, and then this right here is 11 feet, right? Okay, I gotta figure out the pitch of the roof. Well, similar to the last one, I think I could probably pop in a right triangle to help me figure this out. And I know the pitch of my roof is going to be that angle right down there, right? Well, do I know any of these sides? Ooh, I think there's another piece of information I might want here. Okay, so I added in another piece of information. It's 20 feet wide. Let's jot that down. My apologies for not having that in there right away. So let's say this is 20 feet wide. Okay, so these are the dimensions of the garage, right? So how can we figure out the pitch of the roof? Well, let's think here. If this is 20 feet wide, half of it's going to be 10 feet, right? So that's the one triangle dimension. Now, do I know anything else? Do I know either this guy right here or just this right here? I actually know the height of that triangle. If the height of the wall is 8 feet, but the overall height all the way to the peak is 11, this guy's going to be 3 feet, right? This is a common thing. We're not always given every single little dimension. We might have to do a little bit of math to figure out missing dimensions, okay? So I'm going to pull this off to the side so we can work with this triangle. I'm trying to find that angle. We'll call it angle theta. This guy is 3 feet and this guy is 10 feet. And I want to know my pitch of my roof. Well, how am I going to do that? Let's see here. What kind of sides do I have? Across from the theta, pop a right angle there. Across from the theta is 3 feet. That is my opposite side. Next to the theta is my adjacent side. You're going to find a lot of these problems end up using opposite and adjacent. It's an easy dimension for us to get, so we end up using that probably the most often is opposite and adjacent sides. Well, what function goes with opposite and adjacent? Tangent. So if I've got the tangent inverse of my opposite over my adjacent, I will be able to get myself an angle. Let's calculate it. So I plug this into my handy dandy calculator. I end up with the degree measure of 16.6992, so we'll say 16.7 degrees. That is the pitch of my roof. We know from one of the other the last problem we did, that if I were to cut my rafters, this is obviously a much more mild pitch of this roof. My miter cuts are going to be 16.7 degrees for these guys. Okay? Sound good? Awesome.